late notice, but it was really last minute decision. A student asked me and I decided to do it today. Okay. So you can see my face? Yes, no? Okay. Because I don't see yours. Why? Okay. I'll let you know. Somebody asking about the next exam. We'll start with this information. So yeah, today I'll give you information, and then we'll talk about some of the material for the exam, both on forecasting and inventory, but inventory will not be today. We'll have more meetings. So okay, I think we can start officially. Nice to see you guys. And I hope you still are happy to see me after all the flood of material that I sent to you. To be honest, I wasn't sure that I'll have Zoom meetings for this first week because I wanted to rush and prepare and give you something to work with. And this takes time. As you could see, it's a lot of work to do. And therefore, I didn't want to bother myself with meetings. But once I finished the inventory almost, I think it's almost, then I felt better. And then I said, okay, now I can move on to the next stage. We still have time before the exam, so I didn't want to postpone it. So today I'll talk about the seasonal model and about linear trend models. So the linear trend will be more review because we talked about it before. The seasonal, to some of you will be new, and I hope the PowerPoint did help here to understand what's going on, but I will demonstrate a few things on the screen also. So just, you know what, I see here Giovanni. Giovanni is here, right? I'll release your microphone. Let's see if I can. Giovanni, are you hearing me?
Yeah. Hello.
No?
Hello? Hello?
What
Can you hear me?
here? No, I don't know. So because I want to know, I wanted to ask a question. Janet, yeah. Okay, Sagida is here too. Okay, so I want to make some presentation of first of the seasonal model, and I see more people are still coming. So should I wait for a few minutes or not? I really don't know. I'll start. So the seasonal model is newer than the linear trend. So I want to share with you something on the screen, and I need someone to tell me, or whoever, that you can see it and everything works. Okay, so I'm going to share. I'm going to share. Okay, Ricardo, can you tell me if you see the template? It should be familiar to you, this template on linear models.
Yes.
Ricardo Romero, well, right now I can't see because everything is shared and my picture is very small on the right-hand side. Okay, so we are talking about linear trend models that are changing the level of the time series in a linear fashion. So normally, we are going to use linear regression, which is the template I am showing to you now. This time series can be proven to be linear if I first can drag and draw just for the general idea. And as you see, this really requires, reminds you a linear behavior. But to be a little bit more sophisticated, we can run regression and see if we can establish linear relationship here. So with data analysis, we can do just that. The Y value that we have to enter here is obviously the time series. Then the X will be the time itself under period. Sometimes it's called period, sometimes it's called time, sometimes it's called the letter T. Up to here. And the results say I place here. So, as you see, we have the regression. And here are the result of the p-value. The p-value is the one for the test of beta 0 or beta 1. Beta 1 is the slope that is attached to period. And because it's so small, it is less than any alpha, and the null hypothesis can be rejected. So beta 1 is not equal to 0, and we have a time series with a trend. Now, let me get out of sharing for a second because I forgot to start the recording. So I'll share again. So again, we were testing the time series for beta 1 being 0 or not, and rejected that it is equal to 0 because of the p-value. And so now we can proceed with a linear trend time series. To make forecasts for, in this problem, it was requested to take forecasts for the next 2 periods, which I entered here. You see, we have 24 data points, but I entered 26 here. 24 data points, and I added 2 more here. So the regression, the forecast, which is the regression actually, were calculated down here. How was it done? Well, we take the equation from here. We take the equation. And we can write that f of period 25, which is 24 plus 1, is equal to, so we have an intercept of 406.6 plus 10.17 times, and the time now is 25, and this will give us a forecast for period 25. A forecast for period 26 will be done in a similar manner. So it's 406 plus 26. So that's how you get a future forecast with a regression. In this case, in my opinion, this is a time series that is so tight and the variation up and down is so small that a regression will give you a very high correlation, R square, I mean, and so the prediction are supposed to be very good if you don't go too many periods into the future. Now, the prediction interval added here will give an idea how wide the uncertainty takes you around the line. And the narrower the interval, the more accurate the prediction without losing on the confidence level. So that's what this template is giving you, as you see, which doesn't mean that it's always going to behave as good as this one, because this is a really, really unusually linear time series here. When the time series is a little bit curved, then the linear regression is not the tool to go. It might be regression, but not linear. It might be holds if the change in slope is gradual and not sharp, but certainly not linear regression. In our course, you will not see these problems. It will be quite straightforward, and you will be told to use regression or to use later the Holtz method, and possibly to determine which one is performing better, as usual with one of the criterions. So this is about the linear regression, not much to say more, and I can stop the sharing now and to see, and the recording also, to see if you have any question. Let me do it, and if there are questions, I'll let you ask, because I want to move to another model. Stop recording. Okay, so if there are any questions, I'll take them now. You will not say them, but you can write them and I'll try to respond. If I see that there are none and everything is clear, I'll go to the holds. Great, okay, so, okay. What? Okay. I'm trying to see if anybody has asked a question. Okay, so far so good. Where did I get the data from? I think this is one of the data sets that I sent to you in the one of the files, but the data that I took, I found on my computer a data set. You can have it because it's recorded, and I'm going to put it on Dropbox as usual. So when you watch it, that's what I don't know. I don't know if you download it to your machine. If you can, because it will be very large, then the file will remain in Excel. If it is not, then you will be just copying it into your template and you can run it yourself. Okay, so at this point, I think, somebody asked me if I allow you to record the meeting. If you feel like, I can't tell you not, but I'm recording it as we speak. Well, not this portion. I stopped it for a second to see the questions, but I'm going to resume recording, and eventually you will have the whole thing. So I hope this helps.
Okay, so I'm going to continue now. I don't see any more questions. Okay, so I'm going to move to, I'll share it again, and I'm going to the Holtz model, to the seasonal model, sorry. I'm using the template because it will help in entering the data. You see on the screen, just a moment again, I forget to, yeah, I want to record. Okay, good. Yes, so there are two time series, both are seasonal. And for you to see that, let me start with season number 1. Okay. So now it's really hard to tell, right? That it's seasonal. It can be just random up and down, but a little bit better analysis will show that there are cycles of 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. This is 5. Every 5 is about the drop. The 6th one start lower. So we have 5 data points that are a cycle. Now let me maybe format the axis for a second. Maybe you'll see it better. 10,000, okay. Oh, wait a minute. 10,000. Okay, so maybe now it's better to see here. 1 cycle, 2nd cycle, 3rd cycle. Sometimes cycles are losing their structure and this will reduce the accuracy of the forecasting model. But I'm not saying anything yet about this time series, if it's good or not. We'll see it later. So this was 1 time series. And then I'll move to the next one. But I have to change the scale here to, okay, format the axis. And okay, I'll start with 500 here. Okay. So now you see stronger structure. You know what? Seasonality is a time series in which structures are relatively easy to identify. The repetitive manner of the time series is really strong. In the retail area, every retailer will tell you that products are seasonal. Especially when they are weather related, of course. You see this sweatshirt that I'm having here is not sold in the summertime or even in the spring, but will sell high in the winter time. And this repeats itself every year. So you see a kind of wave type behavior with high and lows and high and lows, and that's for sales of this. I mentioned in the PowerPoint that sometimes seasonality is related to the calendar itself. If you know that you have a business that have huge sales just before Christmas, then you see a top sales, a peak in sales before Christmas, and it happens every year. So if you look at the whole year, there is a peak there, and it might not be the only one. Even some other establishments, such as Carl's, they see, say, reduction in sales before Friday and an increase on Sundays, and it repeats itself every day. So seasonality can go quarters, seasonality can go by months, can go by days. It all depends on what the time series describes. But by and large, it's quite easy to determine how many seasons are there in a cycle. In your case, I'll tell you. I will not ask you to determine. There are statistical methods that do that, actually. But we are in this course not asking to do that. I'll tell you how many seasons there are. And then it will be easy to form the model. Now, the model itself is built on the combination of trend and deviations from the trend in a seasonal manner. So in the model, you will estimate how the trend, which is a straight line, how it looks. And then also in each period, how much of a correction due to seasonality we have to add to the trend line. Thus the name additive model. You see at the bottom here, this is coming from your own template called forecast. So I took this sheet and put it here. It's called the additive model because you take the trend effect and you add to it a seasonal correction. This is not the only way to make the corrections, but this is what this model is doing. So how do you build a seasonal prediction model? We are using multiple regression for that. And the model that we are building has a linear trend component and seasonal correction based on dummy variables. So let me show to you now how you enter the data into Excel. I'll take this time series, say, okay. And enter it here. Then I'll enter here whatever it needs to. It needs the number of periods of the data that were collected. In this case, 26 minus 6 is 20 data points. And the number of seasons is 1, 2, 3, 4. Okay? And then again, 1, 2, 3, 4. So 4. A student asked me once if 4 is always the number of seasons. And of course it's not. I already explained it before. It depends on the case. In the case of cows, the example from before, it's 7 because you have 7 days a week. A good way to know how many seasons to include in your model is to see what is the time units. If these are days, usually it's 7. If these are months, usually it's 12. If these are quarters, by definition, it will be 4. And these are the most popular number of seasons. Okay, someone doesn't work here, I know what. Down here, there should be nothing. Okay, we'll see. Now, yeah, something in the template is not. The numbers should have started here right away. In your template, it will happen. Here, I don't know why. I'll write it down here myself. Okay. This is what should have happened automatically, and this is what will happen when you enter the data. Don't enter anything here. It just, I did it because it didn't work. You enter only the values here. And then these two, and everything else will be entered because it's programmed. So what is the model giving you? Let me write here some breakdown of what you see. First observation, I call it y sub 1. y1. It is equal to, it's a b0, we have an intercept, plus b1 times period number 1. T is 1 times 1. b1 times 1. Plus, then comes the seasonal. So B0 plus B1 is B0 plus B1 times 1 is the trend element of the model. And now the seasonal correction. The variables the dummy variables under 1, 2, and 3 will be seasonal 1, seasonal 2, and seasonal 3. So plus 1 times S1 plus 0 times S2 plus 0 times S3. This is the equation that relates to period number 1. So what does it do? It says that the value y can be explained by a linear trend plus a correction plus a, well, I'll make one, plus a correction due to seasonal number 1. This should be here, I'll correct it. Not 1, but B. B2 times 1 times, because S1 is 1. And then here, B3 times 0, because S2 is 0, plus B4 times 0, because the next S is 0. So what happens is the variable S1 and S2 and S3 are dummy variables. If a time series is falling in a given season, the variable S of that season will be 1, and the other variables will be 0. So how would it look at Y2? Y2 is 584. It will be equal to B0 plus B1 times 2. That's the trend element. Now, correction. Because if time number 1 was season number 1, then time number 2 must be season number 2. So B2 will be multiplied by 0 because now it is not season 1, plus B3 times 1 because it is season 2, plus B4 times 0. That's how the equation looks at Y2. And that's how all the equations will look. And based on this set of equations, Excel is going to build a regression equation that will estimate the values of B0, B1, B2, B3, B4. And that's what we are going to get from Excel. An interesting thing is happening when it comes to period number 4. So Y3, I'll skip. Just tell you that it's going to be B0, B1 times 3, B2 times 0, B3 times 0, and B4 times 1. But what's interesting is the next one. Y4 is equal to B0 plus B1 times 4. And now look, plus B2 times 0 because it's not season number 1, plus B3 times 0 because it's not season number 2, plus B4 times 0 because it's not season number 3 either. If it's neither season 1 or 2 or 3, it must be 4. So this is why I did not formulate the model here with 4 dummy variables, only 3. Because with these 3, I can describe all the 4 seasons. And when you go to Y5, you'll start a new cycle all over again. So it's going to be B0 plus B1 times 5, and B2 times 1 again, like the first one. And we start a whole new cycle. So maybe I'll write it. Okay, I'll write it. So I'll change this one to 5. And then it will be here, it will be 1, and 1, and then at 0 and 0. That's why 5. So now we go back to the template. Notice that you have 1 here and 1 here, 2 here and 1 here, 3 here and 1 here, and 4, 0, 0, 0. So what the template is doing is making it easy for you and save you the time of entering those zeros and ones. Imagine a time series with 200 data points and 12 seasons, like here, and then you understand how difficult it is to start entering all those zeros and ones. This is done automatically because it's programmed. That's why it's important to enter the number here, 20, and the number here, 4, so that the template knows how many columns to build. That's it. And now we are ready to run the prediction equation. So, data analysis, regression. And the Y values are here. The X values, you see, everything is X, time, and S1, and S2, and S3, all the way down are X. So that's the X range. The output, say, I can put it here. And here are the results. Great. So, by the way, take a look at R square. This model is explaining much of the variability of those sales, 95%. The model is very, very significant, as you see. So something good is going on with this model. Either trend works, or the seasonality works, or maybe both works. Something is working. Then we can go to each one of those. But first, let's see what is the prediction equation that we got here. So the prediction equation, I like to write it with the letter F at the beginning because we are trying to make a forecast. F for period T. So what is it? 559.57 plus 90.51 times. Period is time. So, okay, so I'll write it period. Then minus 86.8. 8.8 times dummy variable number 1 minus 450.14 times seasonal or dummy variable number 2 and minus 130 times S3. This is your prediction equation. And so if you have to make a forecast for period T, something we'll do in a minute, you have to know, when I say T here, I mean the period, which period it is, period 25, period 27, period 30, one of the future periods, and then identify which season it belongs to. It will not be so hard here because we started at time number 1 with season number 1. How do I know that? Look at the template. Time number 1, season number 1. It's not always so. So at the end, you have to make a calculation by yourself. If you have to make a forecast for the next period, what season it is, look at how this time series started and how many seasons are there, and make a count. And that's how you will know. So we'll do it in a minute. So that's the prediction equation. Okay. And now, just as an overview of the significance of this model, after we know that something good is going on here, I'm repeating here an analysis that we have done numerous times when we did multiple regression. So I'm looking at the p-values of the particular test for each variable individually. First of all, this one is a test for the linear trend. So the p-value is very, very small. Therefore, as before, we argue there is a linear trend component in this seasonal model. And therefore, the number 90.5 is a reliable number. We can work with this. What we are saying here, that on the average, the time series is moving up by 90.5 units each period, on the average. Then come the test for 1. 1 means S1 here. S1 is the dummy variable for season number 1. So what we are testing to see if a correction at season number 1 for the trend line is needed or not. Why? Because we are testing if beta 2 could be 0. H0 is beta 2 equals to 0 or not. Well, the p-value is 0.37. I'll write it down here. H0, this is what I'm testing here. Beta 2, so beta 2 is estimated by a minus negative 86, is equal to 0. HA, no. So that's the test that I'm running now here. Let me this is the test I'm running now. P-value is 0.37. P-value what does this mean? It means that we cannot reject the null hypothesis that beta 2 equals to 0. It means then a seasonal correction in season number 1 is not needed. We are not saying there is no season number 1 and there is no seasonality in season number 1. All what we are saying that the linear component of the model is going close enough to where the time series is falling in season number 1, so a correction there is not needed. This is what we learn from here. This model does not call for any correction, so negative 86 could be 0. That's all what we are saying. But because the model is significant, we are not going to make any changes in this model. We are going to use this negative 86, but it's just for the decision maker to know that this model does not call for a correction in season number 1. This is not the case in season number 2. So now I'm testing, I'll do it here. H0. Now it's beta 3 equals to 0. Well, beta 3 And this is what we are testing. We are testing beta 3 estimated by negative 450. Okay. So the p-value now is 0.002. This is really a small p-value, and if alpha is 5%, it's smaller than 5%. So now we can reject the null hypothesis for this test. This means that beta 3 is not 0, which means a correction of the seasonal effect, correction to the straight line is needed. And negative 450 here is a reliable number. How do you interpret it? In season number 2, the time series is falling below the straight line by 450 units. This is what it means. And if you look at the next test, that is negative 130, with a p-value of 0.18, we are back in the situation of season number 1. So 0.18 is greater than 10%. Therefore, you cannot reject the null hypothesis. And so when you see negative 130, you would say, yes, the season is falling 130 units below the straight line at that point. But with this test, it is not. So now you would ask, then what do we do? Are we going to eliminate it or not? No, leave the model as is, and I'll draw it now. I'll try to draw it now for you. And use it for forecasting as is. But for the question, are these two seasons really significant in terms of adjustments or corrections needed? The answer is not. The only one that is this one. Still, the question remains what happened to season 4 that does not appear in this equation. So I'll talk about it separately in a minute. For now, let me just do this. This represents the straight line with a slope of 90. You see the 90 here? That's the straight line. So it has 559 plus 90 times 3 period. And the seasons now are like this. Now ignore all these p-values. Just focus on those values here. First of all, season number 1 falls below the trend line. Let's assume that this is time number 1, and we know that it is season number 1 from before. So this is season number 1, let's say, and I drop the time series, the straight line by 86 units. Let's say this is 86. And this is where the time series is supposed to be at time number 1. So it's the straight line minus 86. Then comes season number 2. Oh, I have new guests here. Season number 2 is this, okay? And season number 2 goes down by 450. So you see, this is significant. Went down 450. This is where you find the time series at season 2. Then comes the next one. The next one is season 3. Season 3 will be here. But it goes down only 130. That's 130. So see how this behave. From here to here, from here to here, we are season 3. What about season number 4? Look at the equation of season number 4. In season number 4, the dummy variables, all of them are equal to 0. So what we are left with equals to B0 plus B1 times 4. Okay. This is the linear trend component, not including any dummy variables. So at season number 4, the time series is falling on the straight line itself. How come? Because we have to draw the line somewhere. The straight line we selected will hit season number 4 all the time. This is our reference. We didn't have to do it this way, but that's what we decided to do. So for this straight line, it is going to go through the time series at season 4. This is what's going to happen. So the last point will fall just on the line itself. So the cycle goes below, below, and to the line. Next cycle, below, below, and on the line. And this is how this time series is built. So this is just to explain to you geometrically what is going on. So you have 3 seasons with dummy and 1 where all the dummies are 0 by definition. We decided to do so. And therefore, it will coincide with the time series itself. So now I want to make some forecasts, but maybe I'll stop for a second and stop the recording also and see if there are questions.
No. Cái gì thằng nhỏ chị? Cho chị.
Okay, so 2 students asked about the y-axis. The y-axis is the values of the time series themselves. And yes, I'm going to record it and put it on Dropbox. The exam, somebody asked suddenly in the middle about the exam. Is this what the most important thing now? Yes, I guess it is. The exam, your exam, well, there are 2 exams, one on Wednesday for the Monday-Wednesday class, and one on Thursday for the Tuesday-Thursday class. Okay. Okay. I see that people are talking to one another, and this is not why you're sitting here. Now, do we ever change the estimated trend equation when p-value is greater than alpha? Okay, that's a very good question. If the question is, do we ever change the estimated trend equation when p-value is greater than alpha for a season? Look, one thing is what we do in the course, and one thing what you will do in reality when you work with this for your employer. We are not going to rerun the model several times. You don't have time for that. We will have a model. Once the model is F significant, it means that it's a good model. Not all variables in a good model have to be significant. So therefore, for us, we'll leave the model as is and use it for forecasting and use the statistical analysis as usual, no problem. If you go and use it out there, I believe that if you find variables that are really insignificant, you want to get rid of them. But there are ways of doing it. You have to know what you're doing. So that's why at this point, at our level, it's introductory level. We are not going to change the model, but the question was good. Okay, so I just answered to Holly, who answered about this. Yes, I think you asked the same question that I was just and I just saw your question. Yeah, if the p-value is large, the variable is insignificant. But if you start eliminating seasonal variables, you are hurting the seasonality. Seasonality has number of seasons. You don't want to eliminate them if you are not doing it carefully. So that's why I'm saying, do not touch the model. Use it for forecasting the way it was built, and only if you are asked about which season is insignificant, say, okay, this season is insignificant because the p-value is large. Thank you, Holly. It's a good question too. Okay, so there is only one thing left that I want to show to you on the seasonality, and this is how we make a forecast, which is actually very simple. Okay, so share and record. So now let's make some forecasts here. Let's say we have 20 data points, and I want to make a forecast for period 21. You know, forecast you don't make for past times periods, only for future. F of 20 plus 1. So we are going to have 559.57, and then you have plus 90 times 21. Period now is 21. Now you see I'm not eliminating any value, Holly. I'm not. Minus 86.8. Now I have to know if to multiply it by 1 or by 0, because it's time S1. Well, we have to think of period 21, which season it is. Well, season 1 was period 1 was season 1. So actually we can look here and see that this is 0, 0, and 0. Period 20 was season number 4. So this must be season number 1. Therefore, I'll multiply this one by 1. The rest of the dummy variables are 0, and therefore I don't have to continue anything. This gives me the forecast for period 21. Now, forecast for 20 plus 2. I think you got the idea. Plus 90 times 22. I'll write it, although it's 0, minus 86.8 times 0. Why 0? Because now period 22 is not season number 1. And then minus 450.14. This one will be times 1, because now we are in season number 2. So when I told you at the beginning that you have to count, that's what I meant. Start at the beginning, go cycle by cycle, and make sure that you are plugging in the correct value of the dummy variable. The template will help a lot, because you can see here with which season you are finishing. So if I finish after 19 periods, I'll be in season number 3. So this will be then season 4. That's why I'm saying the template will help you a lot here. And if you have no data set and you just work with an equation with the information that I'm giving you, then count and see which seasons a new cycle is starting, like period 1, then period 5, right? Then period 9, and so on. So that's how you make a forecast. And there is an issue with prediction interval, but I didn't add it here. So this is all about the seasonality. Okay, that's all for today. And now I'm waiting. I don't have to go. I just need to. Somebody asked if the file itself will be shared. As I said at the beginning, you have it as a recording. It will appear. It's a video. You can stop a video, and then you can copy and plug it in. Yeah, I can send the file later but don't count on that. You can copy the values here. It's only 20 values to copy, and then you have the file. Yes. So on Monday, I guess you know it already. We have a meeting, 10 o'clock, and then at 1 o'clock, and also on Tuesday. So Monday I do it for the Wednesday class, and Tuesday I do it for the Thursday class. Although you are welcome to mix. And tomorrow I'll do a meeting for those who couldn't come today. So I may have time to do the holds then. I'd rather not. I want to cover the same stuff for everyone. And then on Monday, for sure, I'll do holds. Yes. I think, yes, all the meetings will be recorded. And although sometimes will be repeating themselves, so I don't see why, like the one on Saturday, tomorrow will be the same like today. And so I don't think I have to have duplicate. But the one on Monday will be different. I'll have the Holt model. I may have another seasonal example. Actually, I think I would. And so it will be different than today. Then I'll put a new recording. Each time I have something new, I'll put a recording. Okay? Yeah. Okay. Any question? Now tell me before you leave, was it helpful for today? You make my day, you know that. You know why? I'll tell you, because at the beginning I didn't think, I'll tell you from my bottom of my heart. I didn't know if I'll have time for Zoom because I need to prepare so much stuff, put it on Dropbox, and I wanted to do it in 2 and 3 days. So I didn't want to promise anything. Once this was, I felt a relief. Then I'll go to Zoom and I'll do it along with the rest of the stuff. But at the beginning, it was a rush to put a lot for you so that you can study. Okay, I hope that PowerPoint is also helping. Okay, then I'll see you, I guess, whenever you want. So remember, so I have tomorrow 10, Monday 10 and 1, and Tuesday 10 and 1. Okay, bye-bye.